Very good evening. Today we are going to see a problem on nodal analysis. Take on this problem. Using the nodal analysis, determine the current I1 to 2 ohm resistor. Where is 2 ohms? Yeah, this here it is 2 ohms. Here current direction also they have given in the problem itself. So we need to determine the current I1. So if you look this problem, it seems to be a very difficult problem like that, but it is a very simple problem. You can easily solve by using the nodal analysis. So here you see how many nodes are there. So 1, 2, and 3. So we mark this node as V1, V2, and V3. Okay. So here one voltage source is there. Here another one voltage source is there. So one voltage source is connected to the reference node and to the one non-reference node. And again two nodes are connected to the non-reference node. Okay, so this is the and here also one resistance is there, here one resistance is there, here one resistance is there. So based on the current from this problem, we can mark the current as, say for example, current is coming like this. So this might be the current is I2. Okay, you can take any notation you want. This might be the current I2, and this particular resistance is I3, and current is going like this also. This is I4. Like that we consider. So it is your own wish. It is not mandated like whether you need to go take here I2, I3 like that. So it is your own wish. You can take any notation, but for our analysis, we have taken as here this current as I2, I3, and I4 like that. So coming to the solution, so if the voltage source is connected between the reference node and the non-reference node, so this is the circuit, no? So so voltage source is there. One voltage source is there, that is 10 volts, is connected between a reference node. What is the reference node? This is the reference node. This is the non-reference node. So if it connected like that, we simply set the voltage at non-reference node equal to the voltage of the voltage source. So, as it is the voltage we have taken, if it is connected like this, if one point is non-reference node and another is reference node, in between that one voltage source is connected, then we can take that voltage source as the say like V1. Okay, so say for example, this the node. So V1 we are directly taking. So V1 we are directly taking the take this as equation number 1. Now coming to the V2 and V3. So V2 and V3 are the two, say for example, this the if a voltage source dependent or independent is connected with two non-reference node, the two non-reference node is, forms the super node. Actually, this is the super node. So between any two nodes, this is the condition between any two non-reference node, if a voltage source is connected or not only voltage source or dependent or independent source is connected, then it is called a super node. Okay, so that is the super node. Now we'll come back to this part later. Now what we are doing is we are framing this current okay, current equation. So by using the Kirchhoff's current law, okay, current law, and also by using the nodal analysis. So can we write I1 plus I4 is equal to I2 plus I3 because the current is coming like this. So this current is dividing into I2 and I3. So I1 plus I4 is equal to I2 plus I3. Can we write like this? So that is what we have written here. I1 plus I4 is equal to I2 plus I3. So what is I1 here? I1 here in this circuit, what is I1? I1 is nothing but V1 minus V2 divided by 2. That is the I1. So if you take the I4, what is I4 here? Yeah, this is the I4. No? It's the I4. No? So I4, how to write? V3 minus V1 divided by 4. Okay. So, or otherwise, the current is going like this. Okay. Current is going like this. So, we can write as V1 minus V3 divided by 4 because this is the node. No? This point only the current is leaving. No? So, this point only two currents are leaving. One is I1 and I4. So, we can write as V1 minus V3 divided by 4. So that is what we have written, V1 minus V3 divided by 4. Next is I2. What is I2 here? Yeah, in this point, what is I2? V2 minus 0, because this is the reference node 0 volt. So V2 minus 0 divided by 8. Okay, V2 minus 0 divided by 8. Next, what is I3 here? I3, here it is I3 is nothing but V3 minus 0 divided by 6, because here it is V3, this is the connected to a reference node. So V3 minus 0 divided by 6. That is what we have written. Now, from the equation 1, we know V1 as 10 ohms. So simply we need to substitute here, and we need to simplify the above equation. So if we substitute V1 to 10, so 10 minus V2 divided by 2 plus 10 minus V3 divided by 4 is equal to V2 divided by 8 plus V3 divided by 6. Again simplifying, taking the common LCM as 24 and simplifying this, we'll get the equation like this. Further simplifying, we'll get to the equation as 15V2 plus 10V3 is equal to 180. Take this as equation number 2. Now coming to the super, this two part is there, this two nodes in between. Two nodes, two non-reference node, one voltage source is connected, independent source is connected, so that is considered as a super. So this particular part alone we are taking here. Okay, so we are neglecting all these things. Only this particular part alone we are taking. So here 5 volts is there. So 5 volt is there. So a super node may be regarded as a closed surface enclosing voltage source and its two nodes. Okay, so it is a closed surface, one closed surface enclosing the voltage source. This is the voltage source and its two nodes. So we can we write V2 minus V3 is equal to 5, that equation. So that equation we are taking as equation number 3. Okay, now what we are doing is two equations are there, 2 and 3. So we are further solving by using the scientific calculator. By solving 2 and 3, we are getting the V2 as 9.2 volt and V3 as 4.2. So V1 is equal to 10 volts already we consider. Already we have taken as we not consider. Already we have taken V1 as 10 volts. So here V1 is equal to 10 volts. So from the problem data, we need to find out I1 through that is current I1 through 2 ohms, because that is only given in the problem. So what we want to is determine the current I1 to 2 ohms. So we need to find out this current. So I1 is equal to, how to write, V1 minus V2 divided by 2. So that is what we have written here, this part. This part. So that we need to find out. So I1 is equal to V1 minus V2 divided by 2. So V1 is 10 volts minus V2 is 9.2 divided by 2. So current to 2 ohms is 0.4 amperes. So that is nothing but I1. So this is the answer for this particular problem. By seeing this problem, what many students, what you'll feel this problem as a very tough problem. Many notes are there here. Many resistors are there. I think it is very difficult like that you may consider, but it is a very simple problem. Easily you can get the full marks for this particular problem shown in the figure. So practice the problems well for your exam, and all the best to everyone.